Recording. So just a quick, I just want to make sure the music off, please. No worries. So just a really quick summary here of what we learned yesterday. We really took three different concepts and brought them together. The first one was Pythagoras theorem, right? When you have two sides, you can use that to find a third side. The second thing we looked at was angle measure. So we looked at these three different types of triangles. There's acute triangles, right triangles, and obtuse triangles. And that just has to do with the angles that are in there. And then we also looked at these side lengths. So we have an equilateral triangle where all the angles and all the sides are the same. We have an isosceles triangle where two of our sides are the same, which means two of our angles are the same. And then we have a scaling triangle where everything's different. Using that information, we were able to solve a whole bunch of different problems here. I'm going to actually scroll on down here though, and we're moving on to this section now. You're going to see this thing right here. There's this little diagram here. What I'm going to want you guys to do is I'm going to actually want you to, oh, we are on page 189. What I want you to actually do is, before we do anything to this, because we're going to mark like the crap out of that thing. It's going to be completely like changed up. I want you to literally draw another one right beside it. And we're going to leave that one blank. Perfectly. As good as you can make it, just straight lines, really. Like I'm just doing something like this. I'm just gonna put, 1, 2, 3, 4, 6, 7, and 8. Just because you're gonna want probably a blank one to look at in the future here. So I just want you to really, really quickly draw a copy of this same picture you see just right beside it. I'll give you 1 minute for that. Zoom. So yeah, we're looking at parallel lines. That's primarily what we're working with for today. We know lots of those in the real world. Train tracks, right? If they'll go on forever and ever, these two train lines will never touch. You see it every single time every single time you drive on the road. You'll never see these two yellow lines in the middle of a highway touch, right? They're parallel. They're the same distance apart from each other. Sorry? Well, we're Saskatchewan. We don't have roundabouts. We have grid roads. We're good. You see it in like football, for example, right? Or I guess any sport. These white lines going across, they're the same distance the entire time. There's these lines right here are 5 yards apart, and they're 5 yards apart no matter anywhere you go. So we see parallel lines everywhere in real life. And that's exactly what these are. They're lines that are the same angle. They will never, ever touch, even if you extended them to like the end of the universe.
Train track set.
Sorry?
Train track set.
Yeah. So we're going to come back to this in a second here. Actually, no, we're not going to come back to it. Everyone should have a little transparent protractor in front of them. What I want you guys just to do is I want you to do your best to actually measure out what these angles are. We know what one of them is. We know this one here is 75 degrees. Before you even start measuring, what do you think that this angle 1 would be, just based on that information, if you had to guess? So before you even measure, if you just had to guess, what do you think angle 1 would be? Thinking 105? And yeah, it would actually be 105. So what I'm gonna get you to do is, using your protractors, I'm just gonna give you like 2-ish minutes, just measure out the rest of those angles. So yeah, some of these angles here are actually going to be the exact same. Most of these angles are going to be the exact same. They're one of two numbers. It's either going to be 75 degrees or it's going to be 105 degrees. We know this because it's a straight line, right? Straight line is just 180 degrees. If this part here, angle 2 is 75, that means angle 1 needs to be whatever's left over. 180 minus 75. Oh, there's only 105 degrees left. So all these angles are going to be one of those two numbers. And there's rules about being able to find that information. And so what we're going to do is, usually what I find is it can get really easy to confuse the different rules and what they all mean. So there's kind of like cheat codes we can do. And as you can probably see from the title of that sheet, literally it says a cheat sheet. So there's 4 primary types of angles we're going to be looking at today. There's alternate corresponding. It's something called co-interior, and it's something called vertically opposite angles. So we're going to be looking at some of this stuff here and understanding what each of them are. So as you guys can see, if you're looking at your sheet here, you can probably tell if you're looking really close that, oh, there's 2 lines here with a little red thing in it. What that means is that these 2 angles are the exact same. If this angle over here was 80 degrees, that would mean this one over here would have to be 80 degrees. But how do we know that? And that's what we're going to actually learn how to do here. So when we have an alternative angle, basically, if you have 2 parallel lines, you know a line's parallel because you can see there's this little mark right here. If you see this little like arrow thing, that means those 2 lines are parallel. They're like train tracks. So the yellow lines on a highway. So what we're going to do is, for every single one of these, all of these lines are parallel. Every single one's parallel. When you have parallel lines, there's rules about them, and you can figure out all the missing angles just based on those rules. So we don't have to use advanced like trigonometry and stuff anymore. We can just use logic and follow in a couple of rules. So we're going to start off here with something called an alternate angle. Let me make that red and make that bigger. So when you have alternate angles, basically these are 2 angles. So these are 2 angles that form on opposite sides of a line that intersects 2 other lines. I'll show what that means in a second. And these are equal. So alternate angles are 2 lines that form on opposite sides of a line that intersects 2 other lines. I know that's kind of a mouthful there, and I'll explain what that means in a second here. So I'll let you put that.
It's just the intersection.
Sorry? Yeah, intersection, yeah. So I'm going to zoom into this picture in a second, and you're going to want to actually like do some of these drawings with me. It's going to be ideal if you have like a second color, like whether it's a pencil or a different type of pen or something. Even your like little blackboard marker will work. You're going to want 2 things for this. Okay, so I'm zooming in. Okay, so what do I mean by this? So 2 angles that form on opposite sides of a line that intersects 2 other lines. A line that intersects 2 other lines, right here. That's this one right here that's going up and down. I have 2 parallel lines, like I have train tracks, whatever it is you want to think. I have 2 parallel lines. I've drawn a line through them. It intersects them, right? It goes through them. That's what that means. So what this means is that these two angles here are actually going to be the exact same. So if this angle here again is 80 degrees, that means this other angle with that red stuff also has to be 80 degrees. So I'm going to be showing you some tricks, easier ways to remember this. So what you're going to want to do is make sure this is really vivid. Again, your blackboard marker might be a good thing to use here, is what we're looking for. We can always identify alternate angles if we have a Z. If we have a Z, and you want to actually write that right there, just a big Z beside the alternate angles. If we have a Z, we can always identify alternate angles. So as you can see here, I've highlighted along these lines, I have a Z. If I highlight along these lines, I have a Z. And the second you see you have a Z with 2 lines, you know that these little like nooks and crannies between them, those are going to be this exact same angle.
Looks like 70 or 10.
Sorry?
70.
Okay, yeah, I don't actually know like the actual angles of it, but yeah, so that's a That's a good thing to put here. If this one here is 110 degrees and you want to write that in, that means first off, this one beside it has to be 70, right? Like that's just how a straight line works. But that also means that this one over here is also 110 degrees. So you want to write that in. And then of course, same thing with over here, right? If this one's 70 degrees, that means this one has to be 70 degrees. The key thing to remember there is the Z. You don't even have to remember that, oh, Z means alternate angles. You just have to remember that, oh, a Z means that there's two angles that are the same. That's all you really need to take away from that. Oh, okay. So we have a Z here, right? You have a C, that means you have a Z, that means you have alternate angles, that means those angles are the same. So now I'm going to go down to these corresponding angles. Now, you know, the mathematical definition there is going to be angles that occur on the same side of a transversal line. I'll explain what that is. Are equal. So for corresponding angles, it's an angle that occurs on the same side of a transversal line. They're equal. I'll explain what that is. Okay, so there's a new word here, and that is transversal line. That all you need to know about that is the transversal line is just, it's a line that goes through two parallel ones, right? It's this one I'm highlighted in yellow. I'm going to erase that in a second, but transversal line, it's just something that intersects two parallel lines. We're going to give those an erase. Okay, so with corresponding angles, all we're really looking for there is we're looking for big F's. Again, we know that this little red line here, that means those angles are the same, right? If this angle right here is 110 degrees, that means this other one here is 110 degrees. And so what we're looking for when we do this, I'm going to use red. What we're looking for when we do this, actually, no, I'm going to use purple. I'm looking for F's. And you can have all sorts. You can have regular looking ones. You can have ones that are backwards. You can have ones that are upside down. But if you have an F, you can find yourself the exact same angle. You can have ones that are backwards and upside down. But the second I have an F, I know that these two angles here are going to be the exact same. So all we need to remember is that, a line's 180 degrees. And I need to remember Z and F, and there's two other ones I'm going to show you, if you haven't picked that up yet. Okay, so I'm going to go down to the next page. Everyone has that? No one's saying no. All right, so co-interior angles. What we're looking for here is we're looking for a C, specifically a weird squared one. So you can put kind of whatever you'd like here, but it's a C. That's what we're looking for. I'll go into the definition in a second. So co-interior angles, what this basically means is if two lines are parallel, we have two parallel lines there. The co-interior angles add up to 180 degrees. So if two lines are parallel, those inside angles add up to 180 degrees. So if this one right here is 110 degrees, this one here is going to be 70.
What did it say?
Oh, if two lines are parallel, the co.
Oh,
How's that?
nice.
Again, what you're looking for there is a C.
Yeah, I got this.
Okay. And I have one more for you here. Oh, I forgot to label this one down here. This one's also same thing.
Let's see.
Yeah, it can be upside down. Technically, that's also a U, I guess, as well. But again, this doesn't matter. You can rotate it, you can make it backwards, you can put it upside down, as long as there's, you know, a C, an F, or a Z, that works. And there's one final letter, and it's something called vertically opposite angles here, which is this one here. So a vertically opposite angle. This is going to be a little bit of a longer definition, so make sure you space it. So angles that are opposite of each other at a specific vertex and are created by two intersecting lines. Ooh. Let me do this. Okay, I'm gonna zoom in actually. I'm gonna make it smaller and I'll zoom in. The angles that are opposite of each other at a specific vertex and are created by two intersecting lines. These angles are equal. Okay. I'm going to zoom out a little bit. Take a final look and look really close, make sure you're still ready. Okay, so vertically opposite angles. There's another letter for this one. It's an X. But it's not just an X that looks like that. It could be an X that looks like this. It could be a really narrow one. It could be a really wide one. But you're looking for any type of an X. Any type of an X. It's two lines just intersecting. They don't even need to be parallel in this case. It's just literally two lines that intersect. So again, this top right angle here is 70 degrees. That means the one opposite of it also 70 degrees. So we have 4 letters. We have 4 letters to work with. We have Z, F, C, and X.
What are the angles for the problem?
Sorry?
What are the angles?
Oh, this one's 70. 70 and 110. Okay. So we have 4 letters. We have Z, F, C, and X. Oops. So I'm just on the first page now. Z, F, C, X. Make that just a bit bigger. This is what we got. So what's an easy way you can remember this? Because this is a random assortment of letters. Easy. Oh, that's not what I meant to do. Zebras find crying X's. They found their X crying. Well, if you can remember Z, F, C, X, that works too. But if you're unsure, zebras find crying X's. It's hard to find stuff to rhyme with Z and X, guys. Okay, that's the best I can come up with. That's the best I can do with that one. So if that helps you remember, great. I can understand that might be tricky though, but you try and find a Z and an X that work together. There's not a lot. So if you want, I'd recommend you write that on the top part of your page there, just so you have a kind of a cheat sheet to go back to. I can grab some after this. Are you able to wait like 20 minutes or so? I'd say grab it maybe from like the men's or something now for now then, if you can. Okay. Cool. So we have this put together now. So we're going to use this information and we're going to go through a couple of examples. And again, it's 4 letters that you need to remember. Okay. So if I'm going to this next one here. So these are some example questions you can find. If you look on the second sheet, there, you're going to see this word here. It's called GCSE. So this is the United Kingdom's version of your departmentals, basically. It's the big test they have, except theirs basically like dictates the rest of your life. Your guys is just a test. So theirs is a lot bigger. People spend literally years studying for it. But that's beside the point. So basically, and this is something you're going to be expected to do, being able to find the angle, missing angles, that's good. But what they actually want you to do is they want you to be able to give a statement for it. And the hardest thing I find students struggle with is being able to put it into words. Why this, why this angle is this many degrees. That tends to be the thing they struggle with, not finding the angle. So it's not finding the angle they struggle with. It's usually given the reason why. So with this first one here, with this first example here, first off, what do you think X is going to be? It's going to be 112. Perfect. You found the angle, and that's going to be really helpful for finding complex problems. But if you're looking at this, which letters can you make? Remember, we have Z, F, C, and X that have both of these in. Yeah, you can make a big F here. So the reason in this case is that these are, it's called a corresponding angle. That would be your reasoning in this case. My reason is these are corresponding angles. Again, most students are able to find the angles. They just struggle with putting it into words why. All right, and so for example, two, first off, what do you think y is going to be? Angle y. Sorry? Thinking 125? And how come you think 125? Sorry?
They're alternate angles.
Yeah, so I can make myself, oh, look at this, I have a z. What's a z? Oh, z is alternate angles. You'd say, hey, these are alternate angles. All right, scrolling down, question 3. Which one do you think this is? So yeah, these are co-interior, right? I can draw a big C. C means co-interior. These are alternate angles. And yeah, for question C, first off, we already know that these are co-interior angles. What does that actually mean? What would angle A be in this case? So what does it mean if something's a co-interior angle? What was our definition for that? So you're thinking it's 127 degrees, and you are correct. Reason you're being is co-interior angles, both of these angles are going to add up to 180 degrees. 180 minus 53 gives you 127. So now we're going to stop giving reasons. Now we just need to think about the reasons in our head. You don't actually need to state them anymore from what we're doing. You just need to actually find the angles now, because that's the primary skill. We need to be able to find the angles. So for example, 4 here, how could I find what X is?
180 take away 40.
It's 180 take away 40. Yeah, you're right. This is the whole straight line here, right? This whole thing's a straight line. So I know that if this part right here is 40 degrees, 180 minus 40, I'm going to be left with 140 degrees for this leftover one here. So this angle here has to be 140. Oh my gosh. And now all of a sudden I have a co-interior angle here, right? Now I have a co-interior. These need to add up to 180, which means this one has to be 40. And oh, now I have a straight line again. That means this one here has to be 140. So that you could use any one of the rules here to really eventually work this out. But yeah, in this case, X is going to be 140 degrees. Because you can usually use multiple rules to figure it out. So that's why we don't really care about a statement anymore. Just this is the angle and we understand why. All right. So we're gonna flip the page over now. I'm gonna go to our last example here before we go to some challenging questions. Okay, so going down to example number 5 here. So now what we want to do is we want to find X and Y based on this information here. And you can figure this out a whole bunch of different ways. What's our guesses for what X would be? Austin, what do you think angle X would be? Yeah, on question 5.
Would be 31.
So you're thinking it'd be 131? Close. This angle right here, the one I'm drawing in blue, that one would be 131. But using that information, now you can figure out X with that.
49.
Yeah, so X in this case would be 49 degrees, yeah. So what you're using there is you're using co-interior angles. You could also be like, oh, there's a big F here. So that works too. So there's a couple ways you can figure it out. What about for question Y? You're thinking Y is 31?
131.
Okay, so you're thinking Y is 131. So how'd you get that?
180 subtract 49.
So you did 180 subtract 49. Ooh, so I see. So I can see why you got to that conclusion. In this case, it's not going to work in this specific case because there's actually 2 lines. So because they're going with 2 lines, this is actually a different angle than this one is. If you were trying to figure out this thing, if you use the co-interior rule here, you're figuring out the co-interior, it would work with this because there's the same line bisected, but in this case, we have 2 different lines going through this. So in this case, it's not 131, but I can see how you got there. It's a very tricky question just for that. So you're thinking 105. So why do you think 105?
Well, I just.
Yeah, so again, there's 2 different lines in this case, right? We have 2 different lines here. So we have to kind of follow along each line. So I'm going to use this top line only to solve this part. I'm only going to use this top part here. So in this case, if I'm going along this line, this one's 75 degrees, which means this one has to be 105. Which means this one right here has to be 75, which means this one over here has to be 105. There's 2 different lines here, and that's the trick part though. That was a curveball question because now we have 2 lines going through our parallel lines. So we use the top one to figure out Y, we use the bottom one to figure out X. So I'm going to give you 2 minutes. I want you to try out.
So why didn't you want that?
Y would be 105. Thank you. Forgot to write that in. I want you to try out the GCSE question 1 and question 2 here. And if you finish, you can try out question 3. I'm going to come walk around in 1 minute. Okay. So for this first one here, what answer did we end up getting?
Where's the first one?
For typical GCSE question 1. Sorry? 113 degrees. And yeah, that's right, because you know that we have a co-interior angle here. You need to add to 180. So that means this one here is 113. We have a straight line. So this one here has to be 67. Now we have another straight line. So this one here has to be 113. You could also just realize that I have a co-interior angle here. That means this one's 113. And now I have And now what you have is you have an X. Oh, opposite angles. That means these two have to be the same. So there's a couple ways you can get the answer. But yeah, it's 113 degrees. Question 2, in this case, it's not actually asking to find angles, it wants you to find the letters that are correct with each other. So which angle is vertically opposite from angle A? D, right? Vertically opposite. Well, we have an X. What's opposite of A? D. You're right. Which angle is going to be alternate to angle C? Yeah, it's going to be F, right? Alternate is that Z, if you remember. It has, make sure it has Z in it, and then you're good to go. It is going to be F. And then what about the last question? Which angle is corresponding to angle F? Thinking angle B. Yeah, so corresponding means that we're looking for an F, right? Yeah, it's going to be angle B. You betcha. Perfect. All right, and last one here. Now, what makes this one harder?
Is the line.
Yeah.
So yeah, that's one thing. There's a second line. It's bisecting through it. It's forming triangles.
Why is just in the middle of.
So that's another one. So there's two things to solve, and Y doesn't look like it has a lot of information at first. And there's a third thing there.
There's one angle, but like there's a triangle.
There's a triangle, yeah. So we have that it's a triangle. We have that there's a line bisecting it. We have that there's, you know, Y out there in the middle of nowhere, and there's also algebra in this.
I don't know.
We have X's in here. So let's see if we can solve this one here. So if we want to work out angle X, so first off, this whole line I'm drawing in blue, what is this line? What's that angle going to be? 75 degrees. We know this whole thing is 75 degrees. So we know that it's 75 degrees. And that's the same thing as how many X's are in there? Well, we have one X, but we also have two more X's of them, right? How many are there in total? There's 3 of them, yeah. So 75 degrees is equal to 3x. Oh, well, I can just divide these both sides by 3, and all of a sudden I'm going to get left with, it's going to tell me what X is. X in this case is going to be 25 degrees. So what's the angle of angle X? It's 25. Yeah, and then the other one's 50. You're right. Yeah. So I'm just going to quickly label that in here. So I know this one's 50 degrees. This one here is going to be 25. You're not going to be expected to do this, by the way. This is not going to be a question you're probably going to see again, but I figured it's good practice anyways. Cool. So now what I have is in my triangle, I have one of those 3 angles. Now I need to figure out, if I figure out what this angle is, this one I'm drawing this little blue arc on, I'll have 2 of the 3 angles. I can then figure out the third one, right? So what could I do to figure out this missing angle right up here? I need to use one of those letters to figure it out based on either the 105 or the 25. So 105, okay. So what could I do? What letters do we see? Well, X and Y, but I mean like from like the zebras thing. You can find a C, yeah. So I can find a C here. So I know that, for example, ooh, that's way too big. Let's do that. So if I have a C here, oh, right here, I have a C. Or are you thinking the other side?
No.
Okay, you're thinking this one. Okay, so this whole thing right here, 75 degrees. What does that mean that this upper angle up here has to be? We have a co-interior angle. Sorry? 105. So now we have 2 of our 3 angles of our triangle. I know a triangle has 180 degrees. We figured that one out yesterday. I can take away my two of my three angles and I'll figure out what the third one is, right? So take away 25 degrees, take away 105 degrees. All of a sudden, I'm going to know that I have 50 degrees. So this angle right here, angle Y, is 50 degrees.
But this is,
Yeah, so yeah, the answer itself is just 50 degrees. Yeah. So X is 25, Y is 50 degrees. That's one way you could do it. Again, there's multiple ways. You could use the co-interior for that. That's fine. You could also realize that, oh, I have a Z here. That could also work. Okay. So we're good with those. Like I said, these are just kind of like cheat sheets for you to be able to use. Because I usually find students kind of struggle with this stuff because it again involves a lot of like memorization and rules and whatnot. So what we're going to do now is we're going to transition back to our workbooks. So we're going to go back to our workbooks here. And so now all I want you to do is I just want you to fill in what each of these angles are. We know angle 1's 105 degrees, angle 2 is 75 degrees. So I'm just going to give you a minute. I want you to just fill in the rest of those angles. For all 8 of those, you should have a number. It's either going to be 75 or it's going to be 105. Okay, so I'm assuming everyone has their angles put in there. So yeah, everything's either 105 or 75 degrees. That's what I put in there. So what we're going to do is we're actually going to scroll on down a page. If you're ever curious how they figure out all these angles, they have reason in here below, but we're just going to skip past it. We're going to go straight to this one here. Question 1. So we have 4 different angles that we're trying to find out. And so if you're ever trying to figure out, like there's a math notation here. There's a way of writing it. Because again, mathematicians were super lazy back in the day. Instead of saying, don't write this down, instead of saying angle 1, make that bigger. Instead of saying, hey, angle 1, is this thing, what we instead do is we'd say that we use this line here, angle 1. This little weird symbol here, that means angle. If you want to see what that looks like, that isn't in my write-in. It's just one page up above. It's this little thing right here. So this means angle 7. This means angle 3, angle 8, angle 4. Just a way of saving yourself time from writing it all. Cool. So I want to know what angle 1, angle 2, angle 3, and angle 4 are. That's what the question's asking us. What's the measures of each of these indicated angles? What's the angle of them? I'm going to give you 30 seconds. Just get as many of them as you can. 30 seconds to get as many of those as you can. All right, so I'm just going to start powering through some of these. You could start it in any order you wanted. There are multiple ways to solve these. I'm just going to show you one for each, okay? If you wanted to find angle 1 here, again, I have 2 lines here. I have 2 parallel lines. Those ones there. That's what it tells me, that L1's parallel to L2, line 1, line 2. All of a sudden, if I'm trying to get to angle 1, I'm looking for any one of those shapes, right? Z, C, F. I can make a Z here. Oh, okay, I have a Z. So that means that these 2 angles here must be the same. Angle 1's 110 degrees. I'm just going to write that in here. So angle 1's 110 degrees. All right, angle 2, again, there's a couple different ways you could do this. I'm going to look here and I'm going to see that, oh, I can make an F out of these 2 things, which means that angle 2 has to be 120 degrees. There are other ways to do it. That's just one. Erase that out. For angle 3, again, there's a couple different ways. One of them is you could be like, oh, there's an X here. And I know that this angle in here has to be 60 degrees, which means angle 3 also should be 60 degrees. You could also just understand that there's a straight line here, so these also have to add up to 180. So there's a couple ways of doing it. Either's fine. I'm just going to say that number 3 is 60 degrees. I had to zoom in there for a bit. And then finally, we have angle 4. Couple different ways. One of them is you could be like, oh, I see a Z here. That works. You can also realize that, oh, there's a straight line here. That also works. Either of them is fine, but you should end up there with 60 degrees. I guess you could also draw yourself an F as well. Okay. So 110, 120, 60, and 60. Those are your 3 different angles there. So in order to move on to our next part, because remember, the title of this unit is not parallel lines and angles. The title of this unit is quadrilaterals. And if you guys like flip through the next couple pages of your books, you're going to see that it's going to start working with different shapes. If you're looking through, you see a whole bunch of different types of questions and stuff like that. If you want to go tackle those, cool. But what I would recommend instead, what you do is we need to make sure we have that line stuff, those angles, concrete. We need to have those down so that we can move on to the next stuff. So what I would recommend that instead you look at doing. Oh, you okay? Oops, not that. Oops. Is this the right one? Yes, there we go. Okay. So what I recommend instead you go do is on the LMS, I have uploaded something for you guys to be able to work on. I have not printed this off because it's just a lot of paper. We're not spending a lot of time with it. You get till probably about after the break for it. So what I want you guys to do is I just want you guys to practice some of these questions. There is an answer sheet there. You could take a pic, you could scan this with your phone. I'll upload the answer sheet as well for this. But it's just time for you guys to be able to work on this. If you see the line, if you see the word that says perpendicular, you can skip it. You don't need to worry about it. If you understand what perpendicular is, cool. That's not really what we care about today. So if it has perpendicular on, go ahead and skip it. You can find this in the LMS. I'll upload the answer key right below it. I thought I did that already. And you're going to get about 45 minutes for that before we keep going forward, just because we really need this skill down. Let me actually upload that.
Then we can just put this on like a random piece of paper.
Yeah, you can just use loose leaf. You can even use your board if you want, and like, yeah. Let me put up that answer key. Oh, you're looking at like that flow chart?
Yeah.
Oh yeah. Here, let me put that in there. So what we're doing right now is, so for the next 45 minutes is, it's just time to be able to review some of that stuff. So I uploaded some practice questions on the LMS for people to try out. Looks like this. And I also uploaded the answer key there. So it tells you what the answer is. Sometimes it actually shows you how you got it. Just because we really need this skill to move on to the shape stuff.
What topic is this?
5.2. Yeah, so if you go to unit 5, you're gonna see there's a 5.2 practice and a 5.2 answer key. Come check how we're doing in 1 minute.
So parallel, no, parallel lines are the lines that don't touch.
Yeah, they'll never touch.
Feeling, this is really loud.
It's 2 months ago, I'm listening to this. Yeah, that's too long. I just.
So, my work on the numbers.
Oh, sorry,
What's the numbers are?
the numbers are,
I said 2 months. Okay, you work on the.
yeah, I recognize.
What? Why?
Yeah, I uploaded, questions that I just answered. And then about 2:15 when we have.
You mean we're not doing that? Quadrilaterals?
We'll be doing that.
We're just starting them. Are you going to choose? No.
I don't. We'll see. We'll see.
You can see that they look. We have to like write on it. No, I just.
You can just do it, yeah, on paper, even the whiteboards, fine.
Are we gonna get like time for our like makeup exams? Like during this week or next?
The makeup one?
Like the ones they're making? Our test?
Oh, for financial literacy?
Yeah.
You'll get some more time for that tomorrow, yeah, yeah.
Did you get our exam back for our exam?
Yeah, all the marks are up to date, yeah.
English one?
Oh, for the English ones, no, we haven't gotten them yet. Sorry, I asked about that and they haven't gotten them yet.
Yeah. So. So perpendicular line is just the line that you can use like a kite,
Yeah, 90 degrees from the line, yeah, so if you had something like,
like a cross.
yeah, like if you had like a line like this, perpendicular would go straight up. If you had a line like this, perpendicular would go straight like that. Yeah, it's gonna form a 90-degree angle, yeah.
So number one, you just gotta write it and draw a line.
Basically, yeah. But feel free, like, to head to the deeper questions, because you only got like 25 minutes for it.
Matthew, what are the
Mhm.
these shapes, like, what is some not in the one you use to number 3 and 4?
Oh, I would bring much of the news right now. Yeah, yeah, you're not gonna really, like, the only name you're gonna need to know is like. I mean, other than the 4-7 shapes, is like an octagon. And. Hexagon, those are the only ones you should